This video is sponsored by Things.com. Churning an STL Mesh file into a 3D printable mold is easier than ever using Fusion 360's new mesh tools. In this video, we'll create a two-part mold using this Among Us file provided by 3D Designer on Things. Download the demo file from the link below and let's get started. From the Insert dropdown, we can select Insert Mesh. Select the file from your computer, followed by Open. We can then define the units. It's important to note that STL files are unitless, so you must select your desired unit of measurement. For example, I'll set this to millimeters. If I turn on the origin folder in the browser, you'll see that we can use the center and move to ground options to center this mesh body to our origin. This step is not required, but it will make it easier to center the part to a mold box. After clicking OK, we have a mesh body and we're ready to create our mold box. Before the mesh updates, we would have been required to convert this mesh to a BREP solid body, followed by cutting the converted body from our solid mold body. The old workflow was challenging and didn't work for complex mesh files with large facet counts. Fortunately, we can now do the opposite workflow by converting the solid mold body to a mesh body, which will allow us to work directly with the STL Mesh file. I'll create a new sketch on the bottom origin plane. We can then sketch out a center rectangle starting from the center origin point. This will serve as the mold box. I'll make this 150 by 150 millimeters. We can now extrude this rectangle, turning it into a solid 3D body. For the height, we simply need to make sure it's larger than the object. At this point, consider if you want to create a pour spout or if you would like to use a flat surface of the object. In this case, we could use the opening from the feet or place a spout on the top of the mold box. If the latter, we'd want to extrude this in the other direction to ensure the feet are fully enclosed. Lastly, I'm going to set the operation to New Component since I didn't start with a component. This will group this new 3D body in a new component. We can then rename this component as the mold box. We can now head to the Mesh tab, which houses Fusion 360's mesh features. In the Create section, you will find the Tessellate feature. Tessellate lets us convert an existing solid or surface body into a mesh body. You can think of solid and mesh bodies as two different languages. We need to convert the solid body to a mesh body in order to utilize the mesh features. After activating the feature, simply select the desired body. We can leave the refinement settings to their defaults and click OK. In the Fusion 360 browser, we can toggle open the Component and the Bodies folder, and you will now see a Mesh 3D body. Notice the mesh facets or triangles that make up this three-dimensional box. We can now use the Mesh Combine feature, which acts similar to the Solid Combine feature. The target body is always the body we would like to apply the operation to, or in this case, the body we'd like to cut away from, which is the mold box. The tool body is our cutting tool or the Among Us body. We also need to set our operation to cut, which will cut the tool from the target body. You will need to select Keep Tools in the dialog if you would like to keep your tool body. After clicking OK, it will take anywhere from a few seconds to a few minutes to process. This depends on the file size and how many mesh facets make up the model's geometry. Once complete, you'll see the Combine feature is recorded in the parametric timeline. Fusion 360's mesh tools are now parametric, which makes working with different modeling types even better. To double check the cut operation, use the Section Analysis tool from the Inspect dropdown. Using an origin plane as a reference, we can simply drag the directional arrow to view the inside of the model. The model was successfully cut from the mesh body, so we can now split this mold box into two or more 3D bodies. You will not find the Split Body command in the mesh tools. Instead, we'll activate the Plane Cut feature, which includes a split body type. After selecting the mold body, we can select the XZ origin plane. Notice we're given a preview of the cut operation. By default, this will trim or cut up to the selected plane while removing everything before it. We'd like to keep both sides of the mold box, so we'll need to switch the type to split bodies. We can also define the fill type. No fill will not add mesh faces to the hole created from the split. Uniform will add a uniform set of mesh faces to close the body, while minimal will use the fewest amount of mesh facets possible to close off the hole. Because we're creating a simple flat surface, both uniform or minimal will work. After clicking OK, you'll find we now have two separate mesh bodies within our mold box component. I recommend renaming these bodies along with your other browser assets. We can also hide one half and hide the Among Us body to check each half of the mold. Everything looks great so far. We can finish this mold off with a pour spout on top and some registration pins to help align the two halves. Be sure to check out the latest 3D modeling challenge brought to you by Things.com. The August challenge includes a FlashForge 3D printer that was generously provided by FlashForge. Things.com is the fastest growing 3D model community where you can search, collaborate, and share your 3D models with others. You can also upload a file to start a geometric search, finding models with similar geometry. Mesh files currently don't allow you to create sketches directly on their faces. We're also limited to the types of construction planes we can use. One workaround is to create a direct edit of the desired mesh body. Notice how we're now in a direct edit contextual mode. This will allow us to create a plane through 3 points on top of the model. Simply select 3 random points on top of the model and click OK. One quick tip, you can click and drag the edges of construction planes to make them larger. This does not affect the plane at all except the visual appearance. Sometimes this can be helpful and make it easier to select or work with construction planes. We can now leave the direct edit contextual mode. With this new construction plane, we can now right-click on it and create sketch. Without the construction plane, we could not sketch on top of this model. One important thing to note, you will find that we have 2 new bodies in the Fusion 360 browser. Anytime you work in the Mesh Direct Edit mode, you'll end up with a copy of any edited bodies. We can always right-click and remove or delete the extra bodies. I'll sketch a center circle out in space, and we can then use a coincident constraint to snap it to the origin point. This makes sure it's in the center of our mold body. We can then extrude this with the solid extrude command. To make sure we extrude far enough, I'd recommend making half the mold visible. We can also add a taper of 25 degrees to make the spout narrow at the bottom. After clicking OK, we'll head back to the Mesh tab, once again turning the solid into a mesh file with tessellate. At this point, we could combine cut the top again. However, because we've already split the mold box into 2 mesh bodies, we would need to use the feature twice. Generally, I recommend against using features twice because of another dependency. Instead, consider how you can reorganize your parametric timeline. Remember that Fusion 360 mesh features are now parametric. We can select both the combine and plane cut features and drag them to the end of our timeline. After the model reprocesses, we can edit the combine feature to include the body of the pour spout. Once complete, we can turn the right bodies on and off, and you'll see that the pour spout is now subtracted from both halves of the mold. To finish off your 3D printable mold, I would suggest creating registration pins on each half. This can be done following the same workflow by first creating a solid 3D body that will then be converted to a mesh body before cutting it with the combine feature. One additional consideration, you can create a copy of the solid body and offset the faces of the copy to allow for clearance of the 3D printed parts. This will allow you to use one half as a negative and the other half as the positive part. Of course, with the positive part, you'll want to use the join operation in the combine command. You can then create unique pins around the mold or use the pattern features to pattern the solid bodies. Lastly, once your mold is ready to be printed, simply right-click on the component and select Save as Mesh. I encourage you to use the new 3MF file extension, which is similar to STL files, but also includes units and some additional metadata. Save as Mesh will also allow you to export each mesh body at the same time by selecting one file per body under the Structure option. Special thanks to the new patrons and those who supported the channel via my Buy Me a Coffee page. Check out our Fusion 360 Masterclass and additional Fusion 360 courses at productdesignonline.com. Subscribe right here on YouTube for more free lessons, and check out our other Fusion 360 tutorials for 3D printing, woodworking, and more.